Okay, so welcome everybody, and welcome to the students that are listening online. I've already lost my clicker, so where'd I put that? I got too many pockets. Here it is. Okay. So like I said, we're doing history of marine science, history of oceanography, and we're going to start off way back in the beginning of civilization. So, because people have been exploring the oceans for that long. It's one of the sciences that people have been engaged in for quite a long time. For obviously, you'll see a lot of it is just due to economic benefits, right? Of knowing and understanding the oceans. This picture here is of the HMS Challenger. You'll see HMS Challenger is very important. It's probably one of the most important, groundbreaking oceanographic voyages that occurred through history. So we'll learn more about that. We'll learn actually quite a bit of that. We learned not only today, but then in subsequent lectures too, we learn more about HMS Challenger. But there's the HMS Challenger. She's all broken up now. All they have left is the figurehead. Do you know what the figurehead is? Figurehead? Yeah, it's like you know how sometimes they put like a mermaid or something on the front? That's the figurehead. So yeah, that's all we have left of the HMS Challenger now. It was all broken up in the 20th century. But anyway, so marine science, has been going on for a long time because people have been exploring the oceans for, since the days of antiquity. And by antiquity, I mean sort of like BC times, ancient Greeks, ancient Egyptians, things like that. So this is actually has anyone ever heard of a fresco?
Yes.
Fresco. What is a fresco?
So they paint into the wall.
Yeah.
Different style technique.
With plasters, right?
Yeah.
So it's a technique of painting. Okay, so this is a fresco. It's not a town or a civilization. A lot of people put that the first thing they put on the first question. It's like, what is civilization? They put fresco. It's not. Fresco is just a painting technique. So anyway, this is a fresco from Thera, the island of Crete. Now, island of Crete. Does anybody know where the island of Crete is? It's in the Mediterranean. It's an island kind of off the coast of Greece, but it's the Minoan civilization. So that was one that was because they were landlocked. They were on an island. They were surrounded by sea and surrounded by the Mediterranean. They were very engaged in marine sciences, right? Or in other terms, marine exploration, exploring the oceans. Okay. So this is Bronze Age, 1400 BC. So this is now 3,400 years ago, right? So it's pretty impressive that was going on that long ago. So, and if you actually look at these ships, pretty sophisticated in a way, right? How are they getting around on these ships? Does anybody notice? Yeah, rows. And actually, you know what? We'll learn this. There's actually a difference between a paddle and an oar, and actually rowing. So there's a difference between paddling and rowing. Does anybody know what the difference between paddling and rowing is? So paddling is what you do on a kayak, right? Where you have an oar and you're kind of going like this. Rowing is when you actually have an oar lock, right? And you stick the oar. You ever see people in the boats and they're going like that, right? And the oar is locked there into the side of the ship, so they have a lot more power and strength to propel the ship. So this is actually an example. You can see these are actually oars, and they're doing rowing, which was one of the first technological advances, right? It's just the difference between paddling and rowing. Okay, so see, these are some of the ancient, this is like the first question here, these are some of the ancient civilizations that were engaged in a lot of exploration. You can see that they're all surrounding the Mediterranean, right? That was a lot of, right, that was kind of the cradle of the ancient world, the first civilizations. Well, the first civilizations started in Mesopotamia, so this is 4,000 BC, 5,000 BC, long time ago. And you can see in this area, there's a lot of ancient civilizations that began with sea voyaging. So I'm sure you know ancient Egypt, right? Crete, those are the Minoans, okay? Crete. Phoenicia. Has anyone ever heard of the Phoenicians? Maybe some of you have. You might know this from the Bible. Has anyone ever heard of the Philistines? Okay? Philistines or Phoenicians. Phoenicians or Philistines is the same. It's the same civilization. So these are people that are living on right here on the, you see how close it is to ancient Israel, right? So right there on the coast of the Mediterranean. Actually, Philistine, the term Philistines, that actually means like seagoing people or coastal people. That's what it means. So the Phoenicians, that's actually modern day Syria. So Syria, that's ancient land of the Philistines and the Phoenicians. Okay. So anyway, Crete, Phoenicia, Egypt, these are all very much exploring the oceans. This is thousands and thousands of years ago, 3,000 years ago, 4,000 years ago, they're doing this. So here are clay, this is actually pretty cool. These are clay models that were entombed with the dead, you know, like mummies and stuff in ancient Egypt, showing, you know, they're using oars. And they did actually, you could actually see sometimes they did have sails, right? The sails were not very sophisticated at this time, so maybe they just knew how to use it. If there happened to be a breeze or something like that, they could use it maybe to go up and down. Now, what body of water were maybe the Egyptians exploring a lot?
Nile.
The Nile, right? So they're going up and down the Nile quite a bit, but they're also exploring a little bit around the Mediterranean. Okay. So this is pretty cool. This is a replica that they built, modern day replica. So obviously it hasn't, you know, it's hard to have a boat survive for that many years, thousands of years. So this is a modern day replica of an ancient Egyptian sailing ship. Okay, so that's maybe what it would look like. Okay, and there's the Nile River going through ancient Egypt. So the Egyptians are mostly exploring, going up and down the Nile, but also into the Mediterranean and into the Red Sea. Okay. So another very prominent ancient civilization, I'm sure you know about, are ancient Greeks, right? The ancient Greeks, very technologically advanced compared to their neighbors. They had these very famous ships. I'll talk a little bit more about them later. But ancient Greeks, Phoenicians, Minoans, were exploring the ancient seas, Mediterranean especially, for a long time. Okay, and actually the ancient Greeks went all over. I mean, you can see this is all the exploration of ancient Greeks. They're going to the North Africa, the coast of North Africa, coast of Spain, all the way up into the British Isles. So the ancient Greeks were even exploring the British Isles at this time. So they were going all over the place. What's kind of cool, these are actually very sophisticated ships that the ancient Greeks were able to build. Again, this is happening, right, 3,000 years ago. They were able to do these things. And this is, again, a modern day replica. So these types of ships are called triremes. Has anyone ever heard of those before, triremes? But they were they're actually very sophisticated. If you take a look at it, it looks pretty sophisticated, right? It doesn't look like a simple little paddling rowboat, right? It has masts, it has, sails, it's got actually a whole deck. You've probably seen this before where everybody's down below the deck rowing the oars, and they've actually taken this. This is a replica, right? So this is a 4th century Greek trireme. They've actually taken this and managed to go across the Atlantic with it, So they could do it. They had the ships to do it, but they never actually crossed the Atlantic, to our knowledge, right? Maybe they did, but to our knowledge, they never crossed the Atlantic. So what do you think was stopping them from crossing the Atlantic?
Fear.
Yeah, probably fear, right? But fear of what?
The unknown.
Yeah, the unknown. And
Pirates.
what's maybe another maybe pirates? I don't know. Could be pirates. But what's something that they had good ships, but something that they lacked at this time?
Storage capacity.
Maybe storage capacity.
Yeah.
Think about navigation, right?
Yeah, they wouldn't.
Did they have compasses or anything like that at this time?
Did they get lost?
Yeah, they could get lost easily. So if you're out in the open ocean, right, you can notice the way that they're traveling. They stay pretty close to the shore, right? They don't want to.
Their draft is pretty shallow, and the boats are really narrow.
Yeah.
So you go further out, you try to get caught in a jam sideways.
Yeah.
So that's probably why they want to, have visual on the land,
Yeah.
just in case,
Yeah.
as they, the routes.
Yeah. Right. So that's
The agenda could row their way back
Uh-huh.
to the land.
But they were able to, with these replicas, to cross the
Probably.
Yeah. They actually did it with the replicas. So, by the way, Tim used this word draft. Has anyone ever heard that term before? Draft is kind of how down, how far down the boat's keel goes and things.
So a lot before, like the blue water with a draft like 5'9".
Uh-huh.
So for instance, if I get in a jam on my boat, and say it flips
Yeah.
And I have a weight, it's like 5,000 pounds.
Yeah.
It counteracts the boat and it'll flip it over.
Yeah.
On its end.
Wow.
But, yeah, actually, messed that boat up, though.
Yeah.
Run it over it.
That's interesting. So anyway, there's the triremes. These are the Phoenicians. The Phoenicians actually built some of the most sophisticated and most well-built ships. Again, this is a 4th century. This is a relief sculpture. Relief sculpture is when you just kind of almost make like a 3-dimensional picture. That's what relief is. But this is again, another modern day replica of what these Phoenician ships would have looked like. This is all the BC times, right? So it's a very, very long time ago. And again, people were able to take this and actually cross, with the replicas, cross the Atlantic. So it's kind of cool. They managed to do that. All right, so moving on, and we've got a lot of things to cover here. So I like looking at all these ancient replicas of these ancient ships. It's pretty cool. But another very important advance that came in marine science is, you probably heard of this before, the Library of Alexandria. Has anyone ever heard of Library of Alexandria? Yeah, a little bit. So Library of Alexandria was a very important, actually, let me see. Oh my gosh.
Do you know what that is?
This is the roof. They're doing all the roof. They're totally redoing
We
the
were in a
roof.
study room, I was like, something's about to come crashing down on us. Like, we're gonna
Yeah. Sometimes I do come into my office and there's like plaster or something, whatever it is, I know what it is, sprinkled on my desk. So.
Some kind of destination.
Yeah, it's just, I think we're gonna have to live with it for a while. They're actually doing the roofs on a lot of different buildings. So, yeah, it's not just Coles, and this is going on. This is a construction project. It's going to go on for like 3 years. Just gonna get used to it. But anyway, Alexandria was kind of the hub of the intellectual world in kind of the, maybe you could say, 1st century AD. Very, maybe sort of 100 BC to maybe 400 AD. So very important intellectual center. And this would all have been in kind of North Africa. So let me see if I have a map that shows you where Yeah. I have to go back to really show you where it is. So there you can see Alexandria. So it was part of ancient Egypt. When Carthage was in that area, it was a very important Carthaginians. Have you ever heard of Carthaginians? The Romans and the Carthaginians. Okay. So Carthage, it's an important Carthaginian city when Carthage was occupying this land. But anyway, Alexandria is right there. Okay. So you can notice it's on the ocean, right? So it's a very important port city. And they actually had this lighthouse that was the biggest at the time. It was a wonder of the world, right? It was one of the biggest, probably the biggest. I shouldn't say one of the biggest. It was probably the biggest lighthouse in the whole, right, in the whole ancient world. Okay, so very important port. It was lit by this huge lighthouse, and they had this library. And these, of course, we don't really have too many pictures like what that library might have looked like. We do have some. We don't really know what the interior is. This is kind of artist conceptions of what this library might look like. But it was very, very important library. I mean, this was the biggest library in the ancient world. They estimate that there were probably 40, somewhere between, and we don't know exactly, we don't have the records. Does anybody know what happened to the Library of Alexandria?
Burned down.
Burnt down, right? It was actually burned by Julius Caesar and his invading armies, right? Carthage was like the mortal enemy of ancient Rome, so it was burnt down. But so we don't have records, but we think that there were probably like 40 to 400,000, somewhere in there, scrolls, right? So ancient texts. Can you imagine the loss of that, all the ancient wisdom that was lost in that? I mean, it was just a tremendous, tremendous, tremendous event. So this was the library. This is the ruins of the library are still here. You can visit modern day Egypt now. Like I said, there are probably 40 to 400,000 scrolls. Now, what the people in Alexandria did is that if there were any ships that came into port, it's a very important port. If there were any ships that came into port, Kaya, right? Are you? Kayla, sorry. Kaya sits in. Okay. Did you get, you know which lecture assignment we're on? Everything? Okay. So, anyway, Where was I? Oh yeah, so what they actually did is they forced any ship that came to port to hand over any scrolls or charts or maps that they had. See? So by that, they were able to make copies. So they have this, all these scribes making copies, because of course there were no photocopiers back then. So if you wanted to copy something, what did you have to do? You have to write it down, right? Somebody had to actually physically write it down by hand. So they had scribes back then who knew how to write. They would spend all their time writing and copying scrolls and ships and charts and maps that were on board those ships. So this was so important because we were able to conglomerate all of our knowledge of the world's oceans together. So this is a map put together by Ptolemy. Ptolemy of Alexandria is an ancient scientist, right? So this is 1st century BC. So this is 100 BC, something like that. And they were actually able to put together what is really a pretty comprehensive map. So he was able to put together pretty good, right? I mean, if you look at this, you have most of the coast of North Africa. You have Arabia, the Arabian Peninsula. You have India, right? Or actually, that's probably supposed to be India. I can't really tell. But you have India. You have a lot of Europe. You have the Iberian Peninsula. Iberian Peninsula is Spain, modern-day Spain, Portugal. And you have the British Isles. You even have little hints of Scandinavia, right? Like this would be modern-day Sweden, modern-day Norway. So you can see it's pretty impressive that, of course, one voyager didn't do this. This is conglomerating together all of the ancient wisdom and ancient knowledge of the oceans at that time. Obviously, there's no New World, right? There's no Americas because people hadn't visited it yet. People that are from this part of the world hadn't visited it yet, so they didn't have any idea. So anyway, where are we now? So major contribution of Ptolemy, you've got that, number 4, right? So he put together this map. Now, next one is, again, a huge contribution by the ancient Greeks. So they made many huge contributions to science, but one of them that I think is just really cool. This is Eratosthenes. So this guy here is Eratosthenes. Now what Eratosthenes was able to do, this is the answer to number 5, right? What Eratosthenes was able to do is he was actually able to estimate to 99% modern day accuracy the circumference of the Earth, the size of the Earth. Does that surprise anybody? Right? Because look, at this time, they had a map, right? And the map was not that big, right? It was obviously, you only have the eastern hemisphere here. You're missing the whole western hemisphere. And actually, most of the southern hemisphere, too. And Eratosthenes was able to get this figure, this number, for the size of the Earth that was vastly larger than what we knew about, right? What people knew about at the time. So isn't that kind of crazy? Wouldn't you imagine that the people at the time would be like, no way, Eratosthenes, that's way too big, right? It couldn't possibly be that big. Where's all the missing, what are we missing here, right? So it's pretty impressive. He was able to do this it's 99% accurate of modern day values. So is anybody interested to know how on earth he got this number? He was able to, totally nail the size of the Earth, get the circumference of the Earth. So it's very, very simple what he did. He went to this city on the Nile called Aswan. And all he did was measure the angle of the shadow cast by the noonday sun, right? So he had a pole, right? He had a pole sticking up, and it cast a shadow, and he was able to measure the angle, right, between the noonday sun and the horizon, okay? So does that make sense? He got the angle of the noonday sun. Then what did he do? He traveled up the Nile, 785 kilometers, to Alexandria. And he did another measurement of the noonday angle, okay, the angle of the noonday sun. And what he found is that there was a 7-degree difference. There was a 7-degree difference between you know, what that angle was in Aswan and what it is in Alexandria. And he used reason to figure out that, and by the way, isn't this amazing? People knew that the Earth was round at that time. They knew it was a globe. Isn't that funny? A lot of people don't know that now.
I know.
Still wondering that now, right? But ancient Greeks knew that, right? They understood that the Earth was a globe. It was a circle. So he reasoned that he knew that 7 degrees is 1/150th, 1/150th of a circle, right? Because how many degrees are there in a circle? 360, right? So 7 times 50 is about 350, pretty close to 360. So he reasoned that that 785 kilometer journey that he made must be 1/50th of the size of Earth. Does that make sense? Well, 50 times 785 is pretty dang close to, he got it at 39,400 kilometers. The current estimate of today is 40,075 kilometers. Okay, so he really nailed it. I mean, he was beyond 99% accurate. So I find that very impressive that somebody was able to do that back then. Okay, so that was a very important discovery because he's saying, wow, you know, we really only know a very small, looking at these maps, we only really know a very small part of Earth. We're only seeing a very small part of the oceans. Now, unfortunately, like I said, the Library of Alexandria was burnt down when Julius Caesar invaded Carthage, right? Invaded Alexandria. So it was in 48 BC, right? Now, kind of skipping through a lot of other important history, you probably know that the Roman Empire was kind of at the peak of civilization, at the peak of technology during first century AD, and it continued to be so for a few centuries. But eventually, you might know that the Roman Empire collapsed, right? It collapsed sort of. The Western Roman Empire collapsed first, followed by the Eastern Roman Empire many centuries later. But the Western Roman Empire collapsed 370 to 470 AD was kind of the time of that eventual collapse. So these are some very famous paintings of showing the collapse of Rome, the invasion of Rome, the invasion of all the barbarian and Vandal tribes that came in, that eventually led to its demise. Now, you know, after the collapse of the Roman Empire, what happened? We in Europe, I should say, experienced this long age of the Dark Ages, right? Which there was kind of a cessation of technological advances. And that cessation of technological advance, or a lot of, I shouldn't say all, but a lot of technological advance lasted for a very long time, right? 400 to 1500 AD is usually what we consider to be the medieval times, the Dark Ages. Okay? And it's a time in which there's relatively little, technological advance in the marine sciences in Europe and in the Mediterranean world. Okay, so collapse of the Roman Empire is kind of ongoing process, but generally between 370 and 470 AD collapse. And that's the Western Roman Empire. It took a while for the Eastern Roman Empire to collapse. Actually, the last city of the Eastern Roman Empire we'll talk about, that was in 1450 AD, right? It was the collapse of Constantinople, which was the last city of the Eastern Roman Empire. So it took a long time for the East to collapse, but it did eventually. Okay, so what was happening during the Dark Ages in Europe? Not very much in terms of marine science. There was virtually no advance. And what's really amazing is that the kind of ships that were being built, going all through the Dark Ages, it basically didn't change, right? They were building the same sort of ships that they were in antiquity, like things that were like triremes, like Greek triremes, right? So there's very little technological advance in Europe during the Dark Ages in marine sciences. Where some of the biggest advances were being made in marine sciences was actually in ancient China during the Middle Ages, right? So during the Dark Ages and Middle Ages, okay? So one very famous example of this was the fleet of Admiral Zhang He. So as European and Mediterranean cultures were kind of stagnating, the Chinese were making very many impressive developments to their fleets. So some of the things that the Chinese invented you should know about. So this is number 8, right? So number 7 is ancient China. Number 8 is what are some of these technological advances? Well, one thing is the central rudder. The central rudder. So now before rudders, the rudder on the boat, which is center, it's right in the center of the keel, right down the center of the boat. Now before rudders, has anyone ever heard of like what you call the different sides of a ship? You know, there's like a left side, port side and the starboard side, right? So the starboard side is the right side. What does starboard side comes from? It comes from this term, the steering board. So before the invention of the rudder, it's a very old word, right? The starboard side of a boat comes from the steering board. So before the rudder was invented, before the Chinese invented a central rudder, they literally had a board or a paddle that they would use to steer the ship. Has anyone ever seen Moana? She has that paddle, right? She uses it as like a steering board. You'll see it, she's going using it to steer the ship. So. Ship, I mean, it's kind of a catamaran thing, but whatever. But anyway, central rudder. Another thing that they did, they invented the compass. Again, that solved a big problem in terms of navigation. It's a huge technological advance in terms of navigation, because remember, that was the thing that was really stopping the ancient world from exploring into the deep ocean, to the far off oceans, because they didn't really have very many means of navigation. Okay. Another thing they also invented is they compartmentalized the hull, right? The hull is kind of the body of the ship, right? So they compartmentalized it. Well, why would they do that? Why would they break it up into these different compartments? Does that make any sense to anybody? Like, why would they build all these little? Do they just want more bedrooms in there? They put walls up to make more. It's a good idea. It's not exactly the reason though. Yeah. So the reason that they do this, and they do this in modern day ships too, they compartmentalize it because if there's a hole, a breach in the hull, what happens? Only part of the hull will fill up with water, right? Right. So they keep that. They have these things called the bulwarks. Those are the walls that keep the whole hull from filling up with water, right, and sinking. So it made ships more safe, right? And that was another thing that could allow Admiral Zheng He to explore very far distances. So he was covering distances that had never before been done by any of the European nations. Okay. So this was kind of the first time they could build ships, and these ships were huge. So this was the largest ship of the Golden Fleet, and that's Christopher Columbus's, one of Christopher Columbus's ships, shown in comparison, right? And you could see that. So it's like a typical Spanish galleon, right? So this is much, much, much bigger. Look at how many masts you have, right? So this is a much bigger ship. And this was by far the furthest. He was able to take these ships further than anybody had gone before. Further voyage than anyone had gone before. So he developed new types of sails, new types of rigging that allowed larger ships capable of making longer voyages. Okay? So they could now stay out at sea for months and months and months. So they could go further than ever before. So that was kind of the Middle Ages. Like I said, China was dominant in advancing marine sciences. But then the Europeans came back again with the Renaissance. You probably heard of the Renaissance, right? This was the rebirth of European civilization after the long period of the Dark Ages. Okay, so this is happening in the 1500 AD, right? So, like I said, starting in Italy really was the place where the Renaissance began and spread. Eventually through the north, through the northern Germany and Britain, et cetera, But this was a rebirth of technology that was going all through, technology, medicine, music, art, that was going all throughout the European countries. So now watch out because I have a thing here. So there's a historical event that took place in 1453 I'm going to talk about. In 1454 though, in addition, it's not the answer to your question. there was the invention of the Gutenberg printing press. Okay, now that was a huge, huge deal, because remember I already talked about this. If you wanted to copy a book, how did you have to do it before a printing press? You're writing everything down, right? So think about how much faster now we can disseminate knowledge. We have a printing press. Okay, so maybe you've heard of 1454 as the Gutenberg Bible. Has anyone ever heard of the Gutenberg Bible? Anyway, it was the first Bible that was printed with a printing press instead of being written out. Because imagine that, all the Bibles, everything had to be written all out by hand. Right? They had scribes and monks and things like this to do that kind of work. So anyway, now this is the answer to your question. What happened in 1453 that was so important for motivating Europeans to start exploring the oceans? And this is what happened. There was the fall of Constantinople. Constantinople is an extremely important city. It was actually the very last vestige of the Eastern Roman Empire. And this is such a crazy story. I don't know if any of you are into history, but if you look up the fall of Constantinople, it was really interesting. This was a city. It was the last vestige of the Eastern Roman Empire, and it was completely sustainable and self-contained. It was completely surrounded by walls, and they were completely surrounded by the Ottoman Turks, which were their mortal enemies, right? The Ottoman Turks wanted nothing more than to destroy the city and capture the city. They were completely sustainable and surrounded by walls. And they actually had a massive iron chain that protected their harbors and ports and stopped the Turks from making sieges by a military siege of their city by sea. Isn't that crazy? They had a gigantic, you can imagine this, a gigantic thick iron chain that stretched across their harbors and went on for probably a mile, so it's a long chain. And that's what prevented boats from entering their, enemy boats from entering their harbors. So anyway, this was finally destroyed by the Ottoman Turks, 1453, and that was a devastating blow to what? Well, it was right here in this very important, crucial strategic point for European trade. So when Constantinople finally fell, it cut off land routes between Europe and the Middle East and the Far East. The Ottoman Turks were very hostile to all the European nations, so it cut off land routes of trade between Europe and the Far East and Middle East. So what are they going to do now? If your land routes are cut off, what are they going to look towards now? The seas, right? The oceans. So this really gave a big motivating factor to try to explore the oceans again. Okay. So, there's a lot of very famous mariners that came along during this time. I'm sure you all know Christopher Columbus, but there's also, you heard of Ferdinand Magellan, right? Probably heard of Magellan before. He's the first to actually sail across the entire world, right? He circumnavigated the world. Columbus obviously awakened Europe to the existence of this entire other continent, right? So that was an entire other hemisphere, actually, right? So it's important for Europe. And there's also Prince Henry the Navigator. It's very important because he established a very successful mariners' school in what's now modern-day Portugal. So he was a very important figure to help disseminate and teach the marine sciences. So a lot of these guys were Spanish, Italian, Portuguese. These were the people that were really driving the exploration of the oceans during this time. So this is like 1500s, maybe late 1400s, 1500s. So these are some of the first journeys of Columbus's ships to the New World, right? It's actually landing in the Caribbean islands. And these are the various voyages. He made 4 voyages back and forth through the New World across the Atlantic. 1492, of course. I'm sure you all know that date. Here's Magellan's journey. Started off in Spain, right? Circumnavigated the globe. I just find this fact amazing. Of the original 260 sailors, only 18 of them survived the voyage. A lot of them deserted. So, they would pick up more people. But yeah, that's pretty amazing, right? So this is 1519 to 1521. Okay, so not too long after Columbus had made this groundbreaking voyage across the Atlantic. Now, during this time, we had the first Watson-Muller map. This is 1507. This is the first map that shows the New World on it. This is the first map from the Europeans that show the New World, show any of the Americas. And that looks like, this is, of course, mostly South America that you're seeing right here. It's kind of funny because you look at this map. This is probably supposed to be like the Caribbean islands right here. And this is probably supposed to be the South American coast, South American continent. It looks like they have part of like the West Coast, but then most of North America in our country is like totally missing, right? So they just had no clue about this at this time. Okay, so by 1750, Europeans had, as you know, established all these colonies all over the New World, right? So it's showing how the land was divvied up among the different European nations. And by 1750, we had a pretty close to accurate, pretty close to modern day knowledge of the continents and the islands. So you can see this is a map from 1750. You have Australia, right? You have South America, looks almost perfect. Okay, a lot of North America was still unexplored at that time, right? But we had the coastlines. We had some of the, good deal of the interior, at least, to the east of Mississippi, right? But does anybody notice what continent's missing on here? There's one that everybody forgets about. Antarctica, right? So we didn't have you notice there's nothing down there.
Oh, yeah.
Right. We don't have any Antarctica there on the map yet. We have Australia, Antarctica. So this guy, maybe you heard of this guy. Has anyone ever heard of Captain Cook? Captain Cook, he's a real famous guy. So this is around like 1750s into the 1800s. And look, this was actually a painting done right in 1776 when they were doing the Declaration of Independence here in this country, right? So he was a British captain and did some of the first he was important because he did some of the first sort of scientific, just for discovery, just for the sake of discovery voyages, right? Without a real clear economic impetus. He's actually having these funded by the Royal Society, British Royal Society, really actually trying to just discover and understand and know more about the oceans and about the continents. So he was a really good guy. He actually was sort of famous because his sort of style of managing and leading his ship was very different than kind of what the cultural norms were at the time. He was kind of more, I guess you could say, easy on the sailors and treated them a little bit better than what was kind of the standard at the time. And his whole philosophy is to treat them better, then they're going to be better sailors and more willing to follow you. I mean, look at how it ended up with Magellan. He only had 18 of his original 200 and some sailors, right? So he was important for just a lot of reasons, and did many famous voyages. This is his first ship. He led the HMS Endeavour. So what is that? 1768, and you can see he left England and went all across. He was the first to visit Tahiti. He's the first to kind of put Tahiti on one of these maps, right? Visited Australia, Jakarta in Indonesia, right? So he was discovering, for the Europeans, he was discovering a lot of these islands. Of course, there were people living there at the time, but for the Europeans, he was new to them. So these are pictures of the HMS Endeavour and the HMS, this is the Resolution and the Adventure. So this is his second voyage, and this is him in Tahiti. Another thing that he did, he was the first he never actually landed on the Antarctica, I don't blame him, but he was the first to kind of come in sight of Antarctica. So as far as we know, he was the first person to actually set eyes on Antarctica. So it's the first time somebody navigated a ship that far south. So he put Antarctica on the map as well. So here are just some contributions he made, right? Sailed to Antarctica, explored the Easter Islands, first person to cross the Arctic Circle. And explored further than any European had explored up to this. He did a third voyage that sent him to Hawaii. It's kind of the first to kind of make contact between the Europeans and the native Hawaiians. And does anybody know what happened to him in Hawaii? I guess not many people have heard of Captain Cook. That's okay. But there he is. He's talking to the villagers there, and but he got murdered by all the villagers. He got murdered by all the native Hawaiians. Nobody knows what happened because, like in his diaries, he was saying like, "Oh yeah, everything's going great." Seemed like they were very friendly, but then at some point something happened that we don't exactly know what transpired, but something happened. He was killed by the natives. So that was the end of Captain Cook. Very famous and important explorer. Okay. All right, I want to show you a little bit because I don't know. Did any of you ever wonder like how on earth did these people like have any idea where they are? Like, how would you know if you're in a ship? There's just oceans. Yeah, the stars and the sun. So people and also clocks too. So I'll kind of show you how all those things work together to you can figure out where you are in the open ocean where you have like no reference point, right? Because they would put down like we were here, we were at this latitude and this longitude on this day, this latitude, this longitude on that day, right? How'd they figure that all out? So it's before GPS. So one thing that they did is they used something, maybe you've seen this before, but it's called a sextant. Sextant. And actually, has anyone ever gone to like the history museum they have in town, the History Science Museum? They actually have one of these that you can, a real one that, I mean, you can't use it because there's no sun inside there, but if the sun was out, you could use it. So they have, you know how they have the model of the Spanish galleon there at the museum? Maybe if you haven't been there recently, worked with
Is it the one that you can walk on?
Yeah, so one you can walk on. They have like a nice model that's little, but they have one that also you can walk on. And they have a sextant there. And so the way this works is that you can get the angle of a star or the sun. And you can actually use, for example, the North Star. The number of degrees that the North Star is above the horizon, that is your latitude. So you can get your latitude from that. So however many degrees the North Star is above the horizon is your latitude. You can also use the sun and the angle. Remember how Eratosthenes used the angle of the noonday sun to basically figured out his latitude. You can use that too. Okay? So you can use the angle of the noonday sun as well to figure out latitude. Now what about longitude? How do you figure out longitude? That's a little bit trickier. What you have to use, oh yeah, so here's the sextant they have at the museum, Corpus Christi Museum of History and Science, on their replica of a 16th century Spanish galleon. So they have something that looks like that. And the reason they have that hole there is so that if you're doing this on the sun, you obviously don't want to be holding this, looking at the sun. So they would have a little hole there and that would and you'd shine it right there. It would have the sun would have to perfectly shine through that hole and shine right there, and then you know that it's pointing exactly at the sun. That's how they get the angle of the noonday sun. See, this thing is just like a like a protractor, right? So it's just measuring the angle. Okay, so you just point that. You can point that, for example, at Polaris, which is the North Star. You know that all the stars rotate in the sky, but Polaris stays fixed in the sky. Okay, and you can use that to get latitude in the northern hemisphere. Okay, so there you go. Now, how do you determine longitude? You determine it with a clock. How on earth can you use a clock to figure out your longitude? How would you ever do that? Any ideas? Does that make any sense to anyone? Using a clock to figure out your longitude, like how far east or west you are? Think about time zones. So what the mariners would do is they would have a clock that was set to Greenwich, England time, right? England time. And then they would start traveling to the east or to the west. And what's going to happen is, according to that clock, so if that clock's set to England time. So if you're way out in Indonesia, is the time going to be different? Like, is the sun going to be rising? Does the sun rise everywhere at exactly the same time? No, right? You have the time of the sunrise totally changes, or time of the whatever, noonday sun or the sunrise or sunset, it totally changes depending on where you are on the globe, right? So they would use that clock as like a reference point. And then they could figure out, they could judge from when the sun comes up or when it hits the highest point in the sky, they could figure out exactly where they are for longitude. And the way that it works out is that if there's a 1 hour difference, so let's say you see the midday sun, it's in the sky, the highest point at 1 p.m. instead of 12 p.m. That would correspond to 15 degrees of longitude. So that's how they figured out exactly where they were, latitude and longitude, just using, the stars and the sun. You think that's I don't know, I find that very cool. They were able to do that. All right, so not to be outdone, the Americans came into this whole thing here. We're a newly found nation. So one of our first most important gentlemen to start exploring the seas was Lieutenant Charles Wilkes. So he was the first to kind of thoroughly map the coast of Antarctica. Oh, I don't have any questions about Wilkes, do I? No. I'll kind of go over. I just find this is so funny. This is just one of these. I wish I could teach a class on like defunct like scientific ideas or like scientific theories, but this is just funny. Okay, this is a real hole, by the way. At the time, I'm serious, they thought that the Earth was hollow. It's like in the 1800s. They thought the Earth was hollow, and they thought maybe around like, I don't know, Antarctica or the Arctic Circle, maybe there was a hole that would allow you to go down in there into the center of the hollow Earth. It's just a theory. I can explain exactly why they thought that. I understand why they thought that, but it's just like kind of funny they thought. But anyway. Does anybody know what this actually is? This isn't the hole that goes into the center of the Earth, by the way. This is just a copper mine in Bingham, Utah. That's the Bingham copper mine. That's the deepest hole that humans have. I should say the biggest hole, not the deepest, the biggest hole humans have ever dug. Look how you could fit that whole city in there. Isn't that crazy?
You're not worried about that being like that close to the city?
Yeah, I don't know. Maybe I'd be kind of worried. It would just collapse in there. Yeah. What if that wall just collapsed into the hole? I mean,
Couldn't pay me to visit that place.
yeah, maybe a really strong rain shower or something. I guess they're not worried. It makes a lot of copper. They've gotten a lot of copper out of it. Anyway, this guy's also pretty important. Another American is M.F. Maury. Now, M.F. Maury was just a guy who never really sailed the seas very much. He was kind of crippled or somehow disabled. Can't remember exactly how, but he was just had a desk job in the Navy, but he was in charge of all the archives of the different like charts that the Navy ships would bring back. And what he was able to do is he was able to figure out from those charts and the amount of drift that like the different ships would have in different parts of the ocean, he was able to make this incredible synthesis of putting together all the major currents of the world. Now we're going to have whole like 2 classes on currents, just on currents in the ocean. So ocean currents and circulation. So he was able to put together a map which is pretty, I mean, this is pretty impressive. He was able to synthesize all this data and come up with the currents of the oceans, which before this, people kind of knew about currents. They knew they existed. The Gulf Coast current was very famous. This is a real fast stream of water that goes off the coast of like our southeast Atlantic coast to kind of makes a beeline actually straight for England. So you can imagine how much people were using that. But this is the first time. There's a lot of other currents in the world. This is the first time that somebody actually had a comprehensive map of all these different ocean currents. So pretty impressive and a pretty big deal. Okay, so finally getting to the HMS Challenger. We'll just do the HMS Challenger and talk a little bit about kind of modern day, what we do in modern day to study the oceans, and then we'll stop. But HMS Challenger, I kind of started off with this picture, right? HMS Challenger is a very big deal. This is in the 1870s, like 1872 to 1876. And this was the first, like we had, of course, Captain Cook's voyages were mostly about kind of exploring the oceans, but this is the first like really purely scientific voyage in which we're going to try to measure a lot of different things about the ocean that were totally unknown before. Okay, so I'll show you some things that, this was all funded by the Royal Society, again, the British Royal Society. And they sent this, actually inspired by Charles Darwin's voyage on the HMS Beagle. So they sent out the HMS Challenger with a team of scientists for 4 years. And they traveled all around the world, 79,000 miles. It's a long voyage. That's the science crew that was on the HMS Challenger. And they did all sorts of things. They discovered new animals, right? New marine animals, new flora and fauna, new plants and animals. They found the first evidence of life in the deep, so below 550 meters. So you can see these are those very deep anglerfish, right? Before that, they hadn't found life that deep before, so they didn't, they were trying to figure out how deep can it go. We actually now we know that we can have life all the way down to 25,000 feet in the ocean, very deep. They identified 4,717 new species of marine animals. Yeah, pretty impressive. They also measured did a lot of different measurements of depth. And this I just find so crazy. They had a steam winch, right? They had a steam winch, but all they would do to measure the depth, it's the most obvious thing you could think of. They just took a big weight on a rope and sent it down with a lot of rope. And again, does anybody remember how deep the oceans can go? Because Challenger actually found the deepest point. What's the deepest point in the ocean? Does anybody know that? Yeah, the Mariana Trench, and there's actually a point in the Mariana Trench that's the deepest, that's named after the Challenger. It has a real obvious name. Challenger Deep. So you remember, has anyone ever heard that before, Challenger Deep? So Challenger Deep is actually the deepest point of the Mariana Trench. So anyway, I'm just impressed that they knew to bring like 7 miles of rope, right? They said we're going to need this much rope. Like, I don't know who was in charge of thinking, like, how much rope should we bring to do this, right? To send the weight down to the very bottom of the ocean. Somebody thought to bring 7 miles of it. That's how deep Challenger Deep is. It's like 36,000 feet. So beyond 7 miles, 7 point something. They did all sorts of stuff. They scooped up mud and sediments, taking samples of mud and sediments from the bottom, and nobody knew what was on the bottom of the ocean, right? Like really in the deep ocean prior to this. So they have this little scooping box to do that. They took the temperature of the ocean or water everywhere that they went. They were also measuring salinity, right? I'm kind of interested to know how they measured salinity. I don't know if because we've been using a refractometer to do that, but I don't know how. I doubt they had refractometers, so I don't know exactly how they did it. So they're measuring depth, temperature, salinity, all sorts of things. They found Challenger Deep, which is, to this day, I mean, I'm kind of impressed that they found the deepest point of the ocean. Isn't that kind of crazy that they managed to do that? Because I mean, that's still what we consider to be the deepest point of the ocean today, right? So they discovered Challenger Deep, which is, by the way, it's in the Mariana Trench, which is near Guam. Okay, there's Challenger Deep. It's actually deeper than Mount Everest is tall. So like what, 36,000? Well, they have it in meters there, so 11,000 meters. They brought back these really weird things. I'm going to get you some of these to look at. They found these really weird things. We'll learn more about these later. So y'all can take a look at these. These are called manganese nodules, and you can find them on the bottom of the ocean. And they're very strange little like egg-shaped things that are actually very rich in rare minerals. So people have actually thought about how they could mine these things, right? Make a buck off them. So it's kind of interesting. Okay, so there's some other guys. I don't want to spend too much time on this. I've already gone on a long time, but there's some other guys. That's Nansen. I don't know how to say his first name. Fridtjof. It's Norwegian. He was the first to discover that there's actually no land under the Arctic Circle. So remember that there's land underneath the Antarctic ice, right? There's actually continental rocks, right? But there's nothing like that underneath the Arctic. So the Arctic is just sea ice, right? So he was the first to discover that. There's really no land there. It's all sea ice. Do you know how he did it? He specially built this ship called the Fram to beach itself on a block of sea ice. And then he drifted with the sea ice over the North Pole over a period of like 2 or 3 years. What a life. Just sitting there in a little ship for 2 or 3 years in the Arctic Circle. That's what he did to prove that there was no land underneath there, right? It was just ice. Because if there was land, you wouldn't have been able to drift over the North Pole that way with the sea ice. Okay, so anyway, let's get on to modern day things. How we explore the oceans nowadays. This is the Japanese. We have a lot of research vessels, right? Very expensive thing, like $1 billion research vessels. But this is a very famous one called the Chiku. Is it Chiku or Chikyu? I always forget if it's Chikyu or Chiku. It's a very famous, though, research vessel. What do you think this big, tall thing right here is? That's mast from the sail. What's that big, tall thing there? It's a drill rig, right? It's a big drill rig. So they use that to actually have a drill rig that's long enough to go all the way through the 4,000 meters of ocean water, drill into the sediments and the rocks below. Now, that's another close-up view of the Chikyu. Very, very big research vessel. This actually shows you how crazy this is. There's the Chikyu to scale, okay? There's its drill rig. That's how actually all to scale how far down the drill rig can go into the rock and how far down through the water it has to go. Isn't that bananas? I mean, look, it's so tiny and it has that lines go long, 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 long. What happens if it drifts a little bit to the left or to the right? Wouldn't it snap it, right? So it actually has a whole series of gyroscopes and all these propellers that keep it perfectly centered. Because otherwise it would drift, right, with the waves and everything, and snap off the drill rig, right? So it's pretty crazy. Think about, you know how that goes. Has anyone ever seen the drilling like this happen before? They have to have if you become a geology major here, you'll actually see them do this. But they just go section by section with these drill rigs to get it down to however deep, 11,000 meters or whatever. It's pretty crazy. That's what the drill rig bits look like. See, these are all the different sections of the shaft, right? So they have to put a shaft, piece by piece. To make the shaft long enough. So there you go. Oh, Colton, you saw that, right? Remember that? These are all the drill cores. This is all the sediment that comes up. So those are the drill cores. That's what they get. So there's all the different layers of sediment and rock that they bring up from the bottom. Another thing we use is something called multi-beam. We're going to hear a lot about this later, but this is basically echo sounding, right? So it's like sonar. Okay, so it's a real common way that we use to explore the bottom of the ocean. And it can be very sophisticated. You see, look at this. This is a totally only sonar-based image of a sunken ship. And it's a lot of detail, right? You can really see everything in there. And so it's called multi-beam, meaning there are several acoustic beams coming from here. And we're going to, by the way, if you don't understand this perfectly right now, we're going to have a whole class just on sonar, so you'll get it eventually. But this is not to be outdone by the Japanese. The Americans have made an Okeanos, the Okeanos Explorer. One thing I really like about this is that all of the scientific data that they are collecting at the time, especially their acoustic multi-beam sonar readings of the ocean floor, is live streamed onto YouTube. You can watch them it's very, very boring, but you can watch it slowly collect data. I think it's pretty neat that you can do this though, and okay, I don't want to sign in right now, but if you are signed in to YouTube, I guess you can go and look at that and actually watch them collect data real time, which I think is kind of interesting. Okay, and another way that we actually use, the same thing, when they do these what are called ROVs, they're remotely operated vehicles. These are like remote controlled submarines. And they go down and they can explore kind of more in detail. And again, they have all these things, all their voyages that they do, all the explorations they do with these ROVs, they put it all on YouTube and you can watch it. So it's kind of cool. These are just some examples. Can't hear that at all, can you? It's coming from this speaker very annoyingly instead of the... There you go. Ew, that's gross. Great shot. But anyway, these are the kind of just show you examples of the things that they look at. And it's just... I'm just showing you the kind of stuff that they put on there. It's pretty interesting, I think. Okay, it's just, yeah, here we go. Okay, is this more videos? Sometimes this stuff doesn't, oh, there it goes. Ew. A lot of this stuff's sort of gross, I think. That's why I wouldn't be a marine biologist. That's what these things look like, right? Okay, anyway. I don't want to take up too much of your time with videos from the Okeanos Explorer. But the last thing I wanted to tell you about that's an important technology you should know about is something called satellite altimetry. So this is another way that we actually map out what the bottom of the ocean looks like. Which kind of shape, the hills, the valleys. We do it with what's called satellite altimetry. And the way satellite altimetry works is pretty crazy. It shoots a laser from the satellite down to the surface of the ocean. Now the time that it takes for the laser to hit the surface of the ocean is very precisely known. And we can figure out exactly to the millimeter. Probably you've seen this before. Has anyone ever seen these things, like they have like things that can measure how big your room is with a laser? Has anyone seen that before? It's the same principle. Yeah, like that. It's the same principle. So it measures how far that it is from the satellite to the surface of the water. Okay, to the surface of the water. Now here's the question. How could the surface of the water tell you anything about the bottom of the ocean? Way it bends light, that's a good guess. So way light, that's a good guess too, but it's I don't know actually why I asked it, because there's no way anybody can know. It's really weird. Maybe I shouldn't even say it, but those are good guesses though. Those are good guesses. But this is something that's kind of crazy. I just want to introduce you to this idea, and this is the last slide. There's actually, the surface of the water, it's not totally flat. There's actually hills and valleys. And part of the reason there are hills and valleys is because it comes from the shape of the ocean floor. If there's a hole or like a depression in the ocean floor, there's less gravity. And because there's less gravity, there's actually a kind of a bump in the surface of the water. There's a little hill in the surface of the water because there's less gravity. And if there's more gravity, you get the opposite effect. So you can actually, what's kind of cool is that the surface of the water, how high it is actually controlled by the shape of the ocean below. It's weird. It's a gravitational effect. So you will learn much more detail later, but that's just to introduce you. So there you go. Thank you for listening, and I will see you on, what is it? Wednesday, right? And we'll start plate tectonics. We do 2 lectures on plate tectonics, and then it'll be our test after that. So, see you next time.